So you guys already seen the thumbnail, so I think you know what I'm gonna do in this video. I'm gonna design a full header by using two half headers. At first, mm, first, so in this video, I'm going to design a full header using two half headers. At first, you have to understand some basic knowledge about full headers. So I'm going to the writing pad. This is our two inputs, okay, A and B. And this is our XOR gate, this is our AND gate. This is our another XOR gate, this is our another AND gate, this is an OR gate, okay. So A and B gonna be XOR in here. That means A, Allahu Akbar. Sorry, I do not have any writing pad, so mouse is really hard to write. A XOR B. Okay, and in here A and B gonna be AND because this is AND gate, AB. Same as in here, we can see this line, this line, this line, that means C in. So in here, A XOR B, because in A XOR B is going to input in here and C in going to input in here. So A XOR B XOR C in. A XOR B XOR C in, this is the sum, S. And this C in going in here. And here is A XOR B. So this is A XOR B, A XOR B, and it will be AND C in. Because this C in going to this side, and this A XOR B is going by this side. Okay, so this is A XOR B into, AND C in. And this A XOR B and C in, and this AB is going C out. Okay, going C out. That means it is OR, AB. So I'm gonna make this video about Verilog. So I guess you already know about a lot of things about these gates. Despite that, I just thought it will be great to talk about it at first. So I'm gonna share this. Okay, so we are gonna at first take the new project wizard. Okay, next I'm gonna change the location. Let's name it Full-Adder F2H-double-D-E-R. Okay, full to half adder. Sorry, that will be half to full adder actually. Half adder to full adder. Okay, half adder to full adder. Select folder. I'm gonna exactly name same like this one. Exactly same like this folder. Next. Cyclone 4. Okay. Model sim Altera. Next. Finish. Okay, it is gonna take some time, then we'll be go to the next step. Okay, file, new, Verilog HDL. Okay, now in this tab we are gonna write all the codes. So our mission is to design a full header using two half headers. Why two half headers? We just saw there two half header needs to use. Okay, at first I'm gonna write module half adder to full adder, that was the folder name, and first bracket ends. Then what is in here? We saw that in full adder there are actually 3 inputs and 2 outputs. So I'm gonna write all them in here. A, B, C in sum, comma, carry. Okay, right? Carry. Now, in the next step, we have to define in here which is input and which is output. We know A, B, and C in is the input and sum and carry are output. So we're gonna write input A, comma, B, semicolon, output sum, comma, carry, right? We just define them. Now we have to understand some things. To design a full adder by using half adder, we have to define a half adder at first. Okay, so module half adder. If you saw my previous video about half adder, you already know that how to design a half adder. I'm going to write at first input. In half adder there are 2 inputs, A, comma, B. Okay, and 2 outputs, sum. We should write a small letter because we already defined full larger letters in a full adder. So A, comma, B, comma, sum, comma, carry, right? Then what we have to do? Assign, define which is input and which is output. Input is A, comma, B, and output is sum, comma, carry, right? These are output and input. Assign, A-S-S-I-G-N, assign. What we have to assign? We have to assign the operation. At first, you have to assign the sum operation. Sum operation, what it does A and B just XOR. We have to XOR A and B. A XOR B. Okay. Then we have to end. Then another assign, because there is an AND gate. We have to define the AND gate by carry A and B. A and B. This is the AND operation, which defines the OR AND gate. This defines the AND gate, and this sign defines the XOR gate. Now we have started the module, so we have to end the module. End module. Okay, the heck, I didn't write anything. End module. Okay, so we can now call this half adder in our main code because we are designing full adder by using half adder, right? So we can now call this half adder in this full adder. Now I have to talk about something. In here, if you see closely, if you look closely, in here, there is a sum 1, right? S1. This is sum 1 because we have a final sum. And this is carry 1 because we have a final carry, C out, right? We have another C2, right? This is first half adder. Suppose this is second half adder. So we have 2 carries, actually. We have to define differently. Then we have a final carry, right? Exactly same. We have a say S1. That means we have a 1 sum and 2 sum in here. But this one, the final. So we can write S1 and C1, C2. In our main code, we didn't. In our main code, we didn't define C1, S1, or C2, S2, right? So this whole code doesn't know about S1, C1. How can we write them? We have to write OR because they are extra. C1, S1, all they are extra. We didn't write anything. We didn't mention anything. So we have to write where C1, comma, C2. Okay. Now half adder, first bracket ends. What I'm doing, I'm just calling this half adder in here. Okay, this is the same name as in here. Okay, half adder. At first I'm gonna first input A, second input will be B, then we have to S1, right? Wait, we didn't mention the S1 in here. S1. This is our first sum and this is our first carry. First carry, C1, okay? This is for elder letter, okay? Now, second half adder, exactly same. We will mention in second half adder, we saw this S1 is input in second half adder. Suppose this is the second half adder. So there is S1. This is our S1, right? And this is our C in. This is our C in. So in second half adder, we have two inputs, C in and S1. So we have to write second half adder S1. This is our input, comma, C in, comma, S2, C2. Oh, we didn't mention S2 in here. S2, right? So this is our first half adder, this is our second half adder, and there are another OR gate. If you remember, there is another OR gate. We just mentioned this half adder, we just defined this half adder, but we didn't write anything at all about this OR gate. Okay, so we are gonna mention the OR gate now. Sorry. Okay, now how we're gonna write the OR gate? Assign C out, right, is equal to C1. This is the OR sign I'm gonna write, or C2. Okay, this is the OR gate. This sign represents the OR gate. Okay, OR gate is okay. Now I'm gonna end this module. I'm gonna end. So end module. Okay. A B C in sum and carry. Sum carry output. This is input A B. Oh shit, there is a wrong thing. A B and C in was input, right? C in. There is also that's okay. Okay, we're gonna run it. Okay. So it's gonna take a while. You have to keep patient. Okay. It's just running. You can watch it in the left side, okay? If all the options gets completed, then you are okay to run. Okay, no error, I guess. Okay, 0 errors, 29 warnings. You don't have to think about the warnings. If 0 errors, that means your code is okay. Now I'm gonna open the tools, netlist viewer, RTL viewer. You're gonna take some time, then bingo. Your full adder by half adder is okay. This is carry, this is our sum, this is our two half adder, okay? These are two input, A and B, and C in. Okay, so that's all the video.